Hey guys, welcome. Yeah, so our second additional example on integration by parts, and this is the integral we have to work on. And it looks intimidating, but it's actually pretty easy. And in a video I just made, I showed this result here. And I'll link that video below this one, the video showing this result. Yeah? Okay, cool, cool, cool. But otherwise, let's get started with this integral here. And like I said, it's actually pretty straightforward. So let's take this 4 and write it in front of the integral, and that way we'll have a slightly less cumbersome expression inside the integral. So taking the 4 out, we could write integral, and then we have an x, right? We have an x, and then these guys have the same exponent, so we could write them together as 3 over 5 to the x power, and then of course dx, right? Okay, cool. Now since we're doing integration by parts, we know that we have to follow um, the integral of u dv is equal to uv minus the integral of v du. It is, right? Okay, cool. That means that we have to look at this integral, other than this 4 multiplying in front, we have to look at this integral here and identify a u and a dv. Now, when you first learned integration by parts, you should have been told some good rule of thumbs for picking u and dv. And the first one of those rule of thumbs that you should have learned is that you should pick u to be whatever part of your integral will disappear after taking so many derivatives. And so if we went by that rule of thumb, then we should make u x, because after a couple of derivatives, this here would disappear, right? And that's what I mean as that first rule of thumb. But yeah, like, if you make the incorrect choice of u, then too bad for you. No, all you have to do is just like guess again, right? Like life goes on and you'll live and stuff. Yeah, so okay. So then dv is next, right? So we need a u and a dv inside our integral. We picked out our u as being this x, and so dv then has to be the rest of it, which is 3 over 5 to the x power dx, right? And so then v will require that we use this result here, right? So v is going to be it's going to be 3 over 5 to the x power, and then times 1 over the natural log of 3 over 5. And I chose this here as opposed to dividing by the natural log of a here, and a in our case is 3 over 5, right? Okay, because this is our a to the x. And okay, and yeah, you get it. I'm probably over explaining. Yeah, and it's better to write it this way than to have a denominator on the bottom of this. Yeah, okay. Alright, and so all we have left is to figure out what du is, and so du is going to be equal to dx. Got it. So, ignoring this 4 that we need to multiply by, right, setting it aside for now, and oh so lonely 4. Okay, let's set it aside right there. This integral, I won't forget to multiply by the 4. This integral here, which is no longer equal to that, right, because of that 4 being gone, right, so I'll get rid of that. Anyway, this integral here is equal to uv, so that's this guy times this guy. So that's x, and then 3 over 5 to the x power, and then all of this divided by the natural log of 3 over 5, right? So the natural log of 3 over 5, yeah, okay. So this here is uv, and then we need minus the integral of v du. The integral of v is this here, and so we're gonna have to take this constant in front of the integral so that, yeah, it's a bit easier on the eye. So minus v, so v comes with a constant, and the constant is 1 divided by the natural log of 3 over 5. So I'll choose to write that over here, 1 divided by, I'm really gonna use a ruler annoyingly, yes, 1 divided by and that was a minus sign. They're too close to each other. Okay. I left the dot, a residue. Haha. 1 divided by the natural log of 3 over 5. Right? Okay. And, I need that space there, but okay, okay. And then, of course, v, right? And v is, well, I took that out, and so the main part of v, I mean, which is that guy right there. So 3 over 5 to the x, and then du. And du is just dx. Got it. So all we have left to do is integrate 3 over 5 to the x dx. But wait, that just requires that we use this result. We've done it before, which is we've integrated this before and having to integrate dv here to get to v. And so we know that the result to this is that. Notice that it comes with the constant that divides this, and that constant is this here, which is the same as that. So see, that's why I made space here. Thinking ahead, thinking ahead. So squared right there. Otherwise, I could get rid of the integral and just write 3 over 5 to the x. And of course, that also means I get rid of the dx, right? And I need to throw on a plus c. I've saved myself some writing and some time, right? Okay. Oh, seems like I'm speaking in code about a girl. No, just kidding. It's all math. It's all math. All right. I was writing some girl a lot recently, so I am saving myself some writing in more ways than you think. But that's too much information. You don't really care. You just want to know how to do this math problem. So here it is. Plus C, and it's over. All right. Take care. I hope you enjoyed this.